Hey, Professor Sarfo Poku, it's Ashley Allen. Today's August 1st, 2018. This is Bio 240, week 5 video on tidal volume, which has to do with our breathing, our respiratory system. So what I'm going to show or share with you is what we did on our worksheet, how to calculate a few different things in order to find out our tidal volume. The end result is our tidal volume, our ventilation per minute. So we're first going to start out with counting my respirations. This is again kind of a rough estimate, what we're doing experimental here to figure out our tidal volume and the radius, etc. of our exhalation. I'll explain all that as I go along. So first, just so we all know what tidal volume is, it's the measurement of the volume of the exchange of gases at rest. Gases are, in this case, when we're talking about breathing, primarily oxygen and carbon dioxide. So the first thing I'm going to do is turn on my stopwatch here, my timer on my phone, because we're going to count my respirations for 30 seconds. And from there, we'll keep going with our calculations. Ready? Let's go. Awesome. So I got 12. I just want to keep in mind that, of course, when we're thinking about our breathing, we're kind of trying not to control it. Sometimes we control it too much or too less. So that becomes challenging. All of this, again, is a rough estimate. So I have 12 respirations in 30 seconds. That's about average for rest. I'm sitting down. I'm not exerting myself. So we'll take 12. So I'm going to write down 12 here. I'm going to show you my work here soon. So 12 respirations in 30 seconds. Okay. Now next I'm going to breathe into my lucky green balloon, which I've really tried to stretch out. This is challenging because it's supposed to be a regular exhalation into the balloon, but keep in mind a balloon is latex and it has resistance. So I'm going to try to blow all my carbon dioxide into here without exerting too much. But there is a little exertion in order to blow it all out. So practice breath. All right, I think that's about a regular breath without me trying too hard. So we're going to measure this in centimeters. Let's get our centimeter side here. Flip this over, make sure I'm doing this right. Okay, I have about 19.2 centimeters. So I'm going to round that to 19 centimeters is our circumference for our lucky green balloon. So the first thing I want to do is find the radius of this balloon. Now radius is a measurement from the middle of an object to the edge or the perimeter, in this case an egg-shaped balloon. So for the radius, the formula is circumference over pi squared, 6.28. So we will do that. So let's get our calculator out. And our circumference is 19 over 6.28, and we get that lucky number. So I'm just going to round it down to 3. So let's take 3 instead of all of those long numbers to make our math a little more simple. So our radius is 3. Now next we want to find volume. Now remember, our end result is tidal volume. So volume in general is the amount of space something takes up. In this case, tidal volume is, again, the normal volume of air displaced between normal inhalation and exhalation. And I just wanted to point it out, when I counted my respirations, I made sure I did a full respiration cycle. So it was an in and out is 1, not in, 1, out, 2. No, in and out is 1, right? Because that's a full cycle. So back to volume. So volume, what we need to do is, the volume formula is 4 times pi, 3.14 rounded, times r cubed. So our r is our radius, which we rounded to 3. So 3 cubed is 27, right? So 27 times pi, 3.14, times 4 is that. Now this is all divided by 3, and that's our number. So we can round this one as well. We're going to say 113. So our volume here is 113 in the balloon, 113, okay? So the last thing we want to look at is minute ventilation at rest. So how much are we ventilating? How many liters are we ventilating at rest? So what we'll do is we're taking our 113 and we're timesing it by how many respirations did I have in 30 seconds? 12, all right? So there's that. And we're dividing it by 1,000 to make it into liters. And there you go, 1.356. Let's round it, 1.4. And so 1.4 liters per minute is my minute ventilation at rest. And there you go. That's how it's calculated. I'm sure medical professionals have a more accurate way, but it's neat to figure out, just kind of get a guesstimate on what you're exerting as well. I'll probably try it during my exercise portion as well, just to see what I get out of it. All right, thank you. Let me know if you have any questions.